Good morning, class, and welcome to another lecture in sustainable energy technology. So, in the previous class, we had started our discussion on the impact of fossil fuels with regards to greenhouse gas emissions and global warming. Today, we will continue on that path and also start our introduction to renewable energy technology. So, in the last slide of previous class, we were discussing the various scenarios of global warming futures that had been outlined by IPCC panel, the International Panel for Climate Change, Intergovernmental Panel for Climate Change. And they outlined an high emission scenario, very high emission scenario, mid-level emission scenario, as well as low emissions and very low emission scenarios. And we saw that on any scenario other than low and very low emissions, we are getting temperature rise above 2.5 degrees centigrade, which is considered extremely harmful to the future of both the world and human society as a whole. And today we will continue this discussion and see what are the various harms that are being done and are likely because of the global warming effect. So this slide discusses the impact of climate change on various types of extreme weather events. Let's look into this one by one. So here what is being discussed is the response of the climate system relative to 1850-1900 standards. So what we mean here is, suppose a drought had a certain intensity level, general intensity level in a certain region in the 1850-1900 period, how much more intense or how much less intense this drought is likely going to be in the future given a certain level of general warming. Similarly, how much hotter the hottest day in the summer is going to be compared to 1850 to 1900 standard. So suppose you are living in Delhi and there was a certain maximum summer temperature that Delhi would have felt 150, 160 years ago. What is the maximum summer temperature Delhi feels now, given that you have had 1.1 degree centigrade of warming on a global basis? And similarly, what will it feel if in the future, like by 2100, like from around 80 years from now, the warming has gone up to 3 degrees centigrade over the average values, or 4 degrees centigrade over the average values of 1850 to 1900. So that kind of a comparison was made and the results are shown here. So the actual data today is from observed values, and the future predictions come from global climate models and their impact on the local environment. So if you look at this carefully, let us look what the situation is. There are 5 metrics that have been used. The hottest day in a decade, the temperature of the hottest day in a given decade. Okay, that's one metric. The drought intensity, intensity of once in a decade drought. How many times that will happen further? Okay, so suppose an intense drought happened once in 10 years. How many such intense droughts are now going to happen in a decade given the climate has warmed to a certain level? Similarly, precipitation metrics. What used to be a wettest precipitation day in a decade now happens how many times? Okay, so suppose in 10 years, the wettest day that happened in 1850 to 1900, the amount of precipitation that happened on that wettest day, how many such wet events will happen in the future given a certain level of warming? Similarly, the extent of snow cover change, okay, how much that is going to be affected. Then the intensity of tropical cyclones. We see cyclones forming in the Bay of Bengal and hitting the coast of Orissa, coast of West Bengal, coast of Andhra Pradesh regularly. So what would be the intensity of the tropical cyclones today given the level of warming compared to 1850 to 1900 standards? So these are all indicators of extreme weather events. Remember, these extreme weather events are extremely damaging to life and property. An intense drought will result in famine and crop failure. The hottest day in temperature will cause heat wave induced deaths that happens regularly in summer times in India nowadays. Extreme precipitation events is going to lead to flash floods that is going to inundate large tracts of land and cause death and disease in those areas. Change in snow cover will affect the glacials, the Himalayan glacial systems, for example, in India. Intense tropical cyclones will be more damaging to life and property. So these are real tangible impacts of climate change. So what we see here is with 1.1 degree centigrade warming today, the hottest day in a decade is going to be hotter by around 1.2 degrees globally. Okay. While the drought is going to be a single drought that happened once in 10 years would happen 1.7 times in 10 years. So approximately 2 times, right? The wettest precipitation event is likely to occur 1.3 times with as much frequency as in the 1850 to 1900 standard in the areas that are getting wetter. So remember in the previous slides, we discussed that certain regions are getting drier and certain regions are getting wetter. So the drought intensity is rising in the drier regions, drought intensity and drought frequency. Similarly, wet intensity and wet frequency is increasing in the wetter regions. Snow cover is going to decreasing by around 1% overall, though there is much greater loss of snow cover in the Arctic regions, which is warming far more. Tropical cyclone intensities, till now there is no measurable increase in tropical cyclone intensity. Okay, but models predict that future warming is going to increase the tropical cyclone intensity further. So let us look at one of these cases. Suppose the warming is limited to 2 degrees centigrade by up to 2100. Okay, the low emission scenarios, right? So in this case, the hottest day in summer is going to be hotter by 2.6 degrees centigrade more. The dry regions are going to experience 2.4 times the drought frequency compared to what was the case in 1850 to 1900. So an intense once in a decade drought will be happening around 2.5 times in 10 years on an average. Of course, there is no half drought, it's just a frequency value. Similarly, the wettest precipitation event is going to happen around 1.7 times more. The snow cover extent is going to decrease by 9% on a global level, with much greater impact in the Arctic region still. Okay, and tropical cyclones are going to increase in intensity by around 13%. So that is the impact that we are going to see with a 2 degree centigrade rise. Now suppose this is not the case. We cannot limit our emissions and we get a 4 degree centigrade rise in temperature in some of the high emission scenarios. Then the hottest day is going to increase its temperature by 5.1 degree centigrade. Okay, so suppose the hottest day in Delhi was around 45 degree centigrade, it would be 50 degree centigrade on average in summer times. Drought frequency in the dry regions is going to increase to 4 times the drought frequency in 1850 to 1900. So an intense drought that happened once in 10 years in the sub-Saharan Africa is going to happen 4 times in 10 years. So you can think of the damaging effect this will happen on human agricultural systems, human communities, if over 4 years out of 10 the rains fail. The wet precipitation events are going to increase to around 2.7, so 3 times. So a flood event that would happen once in a decade in a region would happen 3 times in a decade. Okay. The snow cover is going to decrease by 26% globally, which is a huge loss, especially in the glacial systems. And tropical cyclone intensities are going to rise by around 30%. So 30% greater damage increase is going to happen. So this is why with each degree increase in the warming, the extent of damage becomes from just bearable to almost unbearable. and which makes the case of why IPCC is saying that the 2 degrees we can technologically manage through greater support, greater infrastructure, but 4 degrees we will have vast regions of the world that are technologically incapable of handling such changes, environmental impacts. And this impact on extreme weather events has already been documented by scientists today. So there was a study in Nature which collected data on heat waves, wildfires, droughts, extreme rain and flooding events, marine heat waves like coral bleaching events, loss of snow cover and intensity of storms. And what they did was what is called attribution science. It's what you would call a very active area of research of how to attribute the increased intensity of a certain event to climate change compared to local weather fluctuations. So this is now reasonably well developed, and what we see is heat related events have become so total between the 2004 to 2018 all over the world there were 60 heat related events. Of these, almost 55 of them became more severe or more frequent because of climate change. So out of 60 heat related events, which means heat waves, wildfires, etc., 55 of them had a discernible effect of global warming in them. There were 40 drought related events, of which 21 of them became more severe because of climate change, whereas the rest had either insufficient data or no discernible influence. Similarly, there were flooding events, and in the flooding events also there were around 40 of them. Out of them, around 20 became more severe and had a distinct signature of climate change, whereas others had either no discernible influence or had insufficient data. Similarly, coral bleaching and marine heat wave events, out of 20, almost 18 were directly attributed to global warming events. Similarly, cold waves became less severe because of the presence of global warming. So extreme snow events or extreme winter events became less severe because of global warming, which caused the temperature to rise globally. Okay, which is also a problem because the less cold spells or cold events there are, less snow or ice deposition is happening and less snow cover there is in the mountains or in the higher latitudes. In storms, the results were mixed. Out of 8 storm events that were looked at, around 1/3 had global warming signatures, others did not. So that is kind of the study that we see a very clear signal in heat waves, wildfires, droughts, extreme rains, ocean warming and loss of snow cover, where global warming effects are already being discernible. And this situation is very important to understand because when we think of heat waves, there are 2 aspects. Firstly, why is the extremes rising? So here is kind of the average temperature in summer, for example, say this is the average summer temperature. Now some days of summer are going to be cooler than average and some days are going to be hotter than average, correct? So you have some extremely mild summer days and extremely hot summer days, whereas most of the days are kind of located around the median. So this is the probability of occurrence and this is the spread. Okay, and you see this is kind of a normal distribution around the mean. So as the mean shifts to the right, the more extreme summer days frequency kind of increases, as you can see here. And what is seen is as the average increases, the most extreme summer days become far more probable. Extreme heat waves become far more probable and milder summer days decrease remarkably in frequency. Right. Similarly, colder days in winter, if the temperature rises or average temperature rises, true cold spells become less frequent and milder winters become more common. And this also has an impact, especially in the tropical climates. Something that was missed when we discussed the temperature rise in the tropics, subtropics, and the high latitudes. We saw that usually high latitudes experience a greater temperature rise, which has a very bad effect on the snow cover there. However, what needs to be understood is there is still some temperature rise in the land masses in the tropical belt as well. And what happens there is that because of the higher temperature, the humidity in that region also increases. So if you can think like this, let us go back to this situation and let's look at the Indian scenario. So yes, the global warming trend is milder, for example, in India and China compared to the higher latitudes. However, one must remember that the summer temperatures are already quite high in India, China, and in the tropical regions. So, once the temperature rises 1 or 2 degrees above the highest possible temperature, it becomes very difficult for human beings to sustain themselves outdoors. Okay. So, in European summer, if the temperature rises from 30 degrees to 35 degrees, it is still possible for human beings to cope to that temperature rise. But in the tropical regions, if the temperature rises from 50 degrees to 55 degrees, it crosses the ability of human beings to live in those regions because the temperature has become so hot that human beings cannot cool themselves or animals cannot cool themselves sufficiently anymore. So even a small temperature rise in the tropics can be far more deadly than a large temperature rise in subtropics where the summer was milder. And this scenario is kind of seen in this wet bulb temperature data that we will discuss. So this is a data from a paper that I extracted. So this is the working capacity of an average human being. Okay. And this is what is called the wet bulb globe temperature. What the wet bulb temperature is the temperature that human beings actually feel. Okay. Because human beings, so the actual temperature that you feel is a mixture of both the temperature and the humidity level. If a summer is very hot and sultry, the discomfort level is far greater than when the summer is hot and dry. Because in dry summer, a human being can sweat from their skin and cool themselves. Whereas if the water vapor content in the atmosphere is already high, the sweating has no impact because the sweat cannot evaporate and cool the human body. So the body keeps overheating because the sweat is not evaporating and able to cool the human body sufficiently. So if the temperature is 30 degrees and the humidity level is 10%, the wet bulb temperature is lower. Whereas if the temperature is 30 degrees and the humidity level is 90%, the wet bulb temperature is higher, which is more harmful. So 30 degrees centigrade with 90% humidity is more harmful to human beings than 30 degrees centigrade with 10% humidity. And the wet bulb temperature is a measure of that, a combination of the humidity index and the actual temperature index. And what we see is human beings, so this is the amount of exertion required in specific jobs. So suppose a human being is doing manual labor, a person is doing manual labor in the fields or in the farmlands or in the industry, and he is spending 500 watts or 500 joules of energy per second in heavy tasks. So such a person can work at his or her full capacity only if the wet bulb temperature is below around 26 degrees centigrade. As soon as the wet bulb temperature increases above 26 degrees centigrade, his or her ability to work at full tilt decreases to only 70% of its capacity. If it goes above 29 degrees, it goes to 50% of his or her capacity. And if it crosses 30 degrees, then he or she can only exert herself at 30% of that capacity which she would or he would be able to do at 26 degrees centigrade. And by 35 degrees, it is impossible for that person to work at that level at all without risking severe overheating and heat strokes. Now, if you are doing a lighter job, the impact is lesser, but still you can see that by the time your wet bulb temperature reaches this dangerous threshold of 35 degrees centigrade, most human beings cannot work in outdoors to any significant level at all. And what is expected in the tropical lands is that this wet bulb temperature is going to cross this threshold more and more frequently, so that human beings, even while resting, will overheat themselves. So everybody will require air conditioning. Consider the impact of that in summer. If everybody requires air conditioning to cool themselves. Remember, fans can only cool you if the humidity levels are low, because it also helps in evaporating your sweat and helps cool you that way. So unless everybody has an air conditioner, human beings, there may be thousands and millions of deaths on those 7 or 8 days when the wet bulb temperature goes above 35 degrees centigrade. Okay. So that is the danger here. Just a 3 or 4 degrees centigrade rise in the summer heat and a similar increase in the humidity content will cause this kind of a tipping point. So with that context, we can look at the expected temperature and precipitation changes globally for different levels of warming. So we will look first at 1.5 degree temperature rise. So here we can see that at 1.5 degree temperature rise, there will be significantly lower temperature rise in India and China between 0 and 1.5 degrees, so lower than the global average, whereas larger temperature rise of 3 to 5 degrees is expected in the Arctic, in parts of Northern America and Europe, and parts of Antarctica and Southern African regions. Okay. So here the temperature rise is again, as we expect, going into the high latitudes and in the land masses. Similarly, the precipitation change, we see that wetter India and associated regions are expected to become wetter, whereas China, northern Brazil, southern Mexico are expected to become drier because of this 1.5 degree centigrade temperature rise. If this increases to 2 degrees, you can see the colors are becoming darker. So the high latitudes are becoming more and more hotter, and other regions are also beginning to heat up. And these precipitation differences between the dry places and the wet places is also becoming more pronounced. And this we can see at 4 degrees, we see almost the entire world has now, the high latitudes have increased to about 7-8 degrees. So it's uniformly dark. And even the lower latitudes in India, China are also becoming very dark as the heating is becoming much greater. And you also see very large changes in precipitation. So what is happening is the world is becoming increasingly hotter, especially the upper latitude regions, and the gradients of rainfall are also changing much more. So the dry regions are becoming much more dry and the wet regions are becoming much more wet, which is an extremely damaging impact. Similarly, this gives you, and we will just quickly go over this, the relative frequency of hot extreme events, so summer heat waves, flash floods, heavy precipitation events for various temperature rises compared to 1850 to 1900 average. Okay. So if the pre-industrial level was 1, what is the relative frequency? Okay. At 1 degrees, 1.5 degrees, 2 degrees of a 10-year intense heat wave or a heat wave that has a 50-year record heat wave. Similarly, a 10-year event intensity of 50-year event intensity. So how intense is a decadal or a 50-year extreme event is, and how many times that can happen. Okay. So you can see the values are between 2 to 10 degrees for 1 to 2 degrees centigrade temperature rise. So yes, the frequencies are increasing, the intensities are also increasing. So The intensity change is this side. So for example, a 2 degree centigrade temperature rise, a 10-year event frequency, 10-year heat wave event that was happening once every 10 years is likely to be increasing in frequency 5 times, while its intensity change is likely to be not very significant. Okay. Similarly, a 50-year event, 50-year heat wave, a heat wave that was so intense that it happened once every 50 years, whose frequency will be increased 15 times more. Expect. So it will happen maybe once every 3-4 years, and its intensity is going to rise by about 2 to 3. Okay. So the rarer events are going to happen more frequently and more intensely, and this is a kind of a very clear pattern that we will also see in the flash floods. The rarer the event is, the more frequent it is going to become because of that normal distribution effect that we were discussing. A 50-year flash flood is going to happen once every 10 years, then once every 5 years, then once every year, and its intensity is also going to increase. Similarly, droughts, etc. Okay. So that's kind of the projected impacts, and how as the temperature rises, those intensities and frequencies are going to increase very quickly. Okay. And it is also going to have an impact on agriculture, right? So here the impact on agriculture is particularly pronounced in the lower latitudes. Okay. The reason is these latitudes are going to get hotter, and some regions are going to get drier, or there will be flash floods in other regions, all of which is going to affect the agriculture. Okay. So because the temperature is already quite high, a 2 or 3 degree rise in the summer extreme temperature is going to burn the crops, and the increased flash floods or increased droughts are also going to destroy the food crop system. So throughout India, the Mediterranean region, Australia, Brazil, Central, Southern America and Mediterranean European regions, we are going to see a projected yield change of greater than 50% in many cases by 2050. Okay. And that is going to have a catastrophic impact on many of these nations. Consider if the yield is decreasing by 50% of the rice, the wheat that is grown every year, how much impact that is going to have. Now there will be an opposite effect in the far northern reaches. So like Norway, Northern Europe, Northern Russia, Northern Canada, because here the winters are going to get milder, so there will be less snow-covered land in the winter. So certain periods of land which was inaccessible to agriculture will become accessible. Okay. So there is likely to be, if agriculture is practiced in those regions, an increase in yield there by more than 100%. Okay. However, remember this is areas which are currently very thinly populated. So Canada's population density is very low. Norway, northern Russia's population density is very low, precisely because these regions are quite cold and most of it is snow covered. Most of human beings live in China, India, Africa, Latin American countries. And in those regions, the agricultural yield is going to drop. So the positive impacts in those few northern thinly populated countries is not going to be enough to offset the negative impact in the highly densely populated tropical and subtropical regions where the yield is going to fall. So the general yield range is expected to decrease by more than 50% if we have the high emissions scenario going on. Okay. Finally, we also look at the ice loss that is happening throughout the world in Arctic and the Greenland ice loss. So Greenland is almost permanently snow covered, and the melting of land ice is going to have an impact on the change in sea levels, right? And we see an impact in the ice thickness over the last 30-40 years. So the surface elevation change. So because Greenland, there is a lot of ice on Greenland, the loss of elevation means the loss of ice. And you see significant elevation changes in the coasts of Greenland where ice loss has been particularly prominent. And you see this ice mass loss has happened in Greenland consistently, especially from 1980 onwards. You see this declining trend. Okay. And this is the global mean sea level rise, in which Greenland ice loss is a significant contributor. So this is the basic sea level rise data up to 2019, I think 2019 or something. And you see the cumulative, the original sea level was 0, say, and today the sea level has increased by around 9 inches from the 1880 mean. Okay. Much of this sea level rise is due to the warming of the oceans rather than ice loss, because as the water warms, it expands in volume. So the sea has basically become hotter and expanded, and so the sea level has also risen. But ice loss has also contributed. Okay. And these are the expected change in sea level in meters now, because the values are much higher for the various cases. So we expect that by 2100, for the high emission scenarios, sea level is going to increase by 1 meter, whereas in the low emission scenarios, the sea level rise is going to stay around 0.5, but it's still going to increase, because what is expected is it will take a significant amount of time till the total heat is actually felt by the oceans and the ice. So the ice is going to continue to melt, and the oceans are continue to get heated up over a longer period of time, even when the CO2 ppms are declining. So there is a strong effect of this on coastal inundations and coastal flooding and inundation of low-lying areas. Remember that much of the cities throughout the world, like Mumbai, Calcutta, Madras, etc., are close to the coast, New York, London. So these are extremely prone to coastal floodings because of tornadoes, high tides, etc. So this has a very harmful impact on human habitation as well. So that kind of closes our discussion on many of the impacts of fossil fuels. We have discussed pollution emissions and the harmful effect on health it causes. We looked at the greenhouse gas emissions, CO2, methane, nitrous oxide, and their impacts today and the future impacts if those emissions are not controlled. So I hope that I have been able to convince you that a transition to a more sustainable energy system worldwide and in India is extremely urgent, which is why both the world, different nations of the world, as well as the Indian government is investing a lot of effort in transitioning from traditional coal-based or diesel or petrol-based energy and transportation technology to more modern renewable systems, CO2 capture systems, biofuel systems, and EV systems when it comes to transportation. And this course will try to give you an overview of these various sustainable energy technologies, how they a basic level, a basic understanding of their role, their basic technological principles, and how they help in improving the sustainability of the energy ecosystem in the world.